Hey everyone, and welcome back to The Explainer. So, today we're unpacking a really high stakes scenario, one that honestly plays out in homes every single day. Picture this: a burst pipe. It can unleash up to 400 gallons of water in just 1 hour. Seriously, that's like emptying a massive hot tub right into your living room. When that happens, or say a huge storm hits, panic is usually the very first reaction. But today, we're tossing out panic and replacing it with pure protocol. We're going to break down the exact science of fighting water damage, turning what feels like a totally chaotic disaster into a manageable step-by-step process. We're looking at the anatomy of a water disaster and figuring out how professional restoration teams use hard science to help you survive this hidden enemy. Okay, let's dive into this. To get you through this complex emergency, we've got a clear roadmap for our explainer today. We're hitting the ticking water clock, the perfect water storm, categories of contamination, the science of drying, and finally, mitigation versus restoration. Let's get right into it. All right, part one, the ticking water clock and why every single minute counts here. You see, water isn't just a static problem sitting there on the floor. It's a fast-moving, invisible enemy that actively gets worse by the minute. To survive it, you really have to understand this timeline. At minute 0, the water enters and instantly starts seeping into anything porous. Then, by minute 60, that's when you need a professional response. This is your absolutely crucial window to stop the bleeding, so to speak. In fact, rapid response teams actually aim to be right there on site with these massive truck-mounted extractors within that very first hour. Now, if the water is untreated, we hit the real danger zone at hour 24 to 48, which is mold germination. But if everything goes strictly according to professional protocol, days 3 to 5 represent complete, verified drying. And that brings us to a really critical number: 48. Let's say you go away for the weekend and a pipe bursts. You do not have days to just wait and see. 48 hours is the exact amount of time it takes for microscopic mold spores to actually germinate in a warm, humid environment, exactly like what we see in our source materials example of Alabama. You literally have just 48 hours before a standard water leak morphs into a full-blown, hazardous mold infestation. Moving on to section 2, the perfect water storm. We're looking at Mountain Brook's unique geographic saboteurs. So, water disasters don't just happen in a vacuum, right? Your local environment can actually weaponize water against your property. Which brings up a really fascinating question. Why are some neighborhoods at a much higher risk for catastrophic water damage than others? I mean, what makes one street totally fine while the next street over is just a massive hotspot for basement flooding? Well, what's really interesting here is looking at a hyper-local hazard zone as a case study. Take a neighborhood like Mountain Brook down in Jefferson County, Alabama. Areas around Cahaba Road and Crestline, they face this literal perfect storm of geography and infrastructure. First off, you've got homes built on slopes where water runoff concentrates incredibly fast. Then you've got these beautiful, mature trees, but their roots are down there cracking underground sewer lines. On top of that, inside these gorgeous historic properties, you'll often find aging galvanized plumbing. That stuff corrodes from the inside out and can just burst without any warning whatsoever. But honestly, the real geographic saboteur here is the dirt itself. The heavy clay soil in that area absorbs water incredibly slowly. So when those intense spring thunderstorms roll in and dump heavy rainfall, the water just pulls up. The clay acts like a giant sponge, expanding when it's saturated, literally crushing the waterproofing right off the foundation walls. Then, when it finally dries out, the clay shrinks back, leaving these massive gaps. So the next time it rains, the water flows right through those gaps and completely floods the basements. It is just this vicious, ongoing cycle. All right, section 3, categories of contamination. Because as it turns out, not all water is created equal. We actually need to shift our focus to the biohazard level of the water itself here, because what is actually floating around in that water dictates exactly how you have to fight it. The industry recognizes 3 totally distinct categories of water contamination. Category 1 is clean water, so think a burst supply line under your sink. Initially, the danger is low, but remember that ticking clock we talked about, it definitely won't stay clean forever. Then there's Category 2, which is gray water. Think of an overflowing washing machine. That carries moderate contamination. And finally, we have Category 3, which is often called black water. This comes from things like sewage backups or river flooding, and the danger level here is absolutely extreme. Category 3 water is, quite frankly, an absolute biohazard. In areas with older infrastructure and those tree root issues were mentioned earlier, sewage backups are a very real threat. And yeah, it's exactly as gross as it sounds. If this black water enters a home, you absolutely cannot just dry the carpet and hope for the best. No way. It requires highly specialized cleanup protocols, heavy antimicrobial treatments to protect against dangerous bacteria, and the complete safe removal of all the porous materials attached. It all has to go. That leads us to Section 4, the science of drying. This is all about objective protocols over guesswork. Now, the good news in all of this is that professionals don't just walk in with a mop and cross their fingers. The entire cleanup process is governed by the IICRC S500 standard. And this isn't just some loose suggestion. It is a heavily regulated scientific protocol. It dictates the exact moisture testing procedures you have to use, sets specific drying goals based on the types of materials involved, and even outlines the precise equipment required for the job. Following this strict standard is also what ensures that insurance companies actually recognize the documentation and approve your claims. It completely takes the guesswork right out of the equation. So, this rigorous standard translates into a very meticulous 4-step extraction and drying process. Step 1 is assessment. This is where technicians use thermal imaging cameras to actually map out the hidden water inside your walls. It's pretty amazing tech. Step 2 is extraction, using those powerful truck-mounted vacuums we mentioned to physically suck out the bulk of the water. Step 3 is the actual drying phase, where they establish these perfectly controlled environments using industrial dehumidifiers. And finally, step 4 is verification, where they use highly calibrated meters to absolutely prove the job is done right. So, how do they actually verify it? Well, they look for specific target numbers, like 12. 12% is the absolute target moisture level for drywall. Your drywall must reach 12% moisture or less to be considered truly dry and completely safe from mold growth. Other materials have different targets, like wood framing might need to hit 15%. But the whole point is, every single material is tested separately until it hits its own specific scientific threshold. But here's the catch. Achieving that 12% is way harder than it sounds, mainly because the local climate is actively fighting the drying process. In places like our source example of Alabama, the outdoor humidity frequently tops 60%. That slows down evaporation immensely. To counter this, technicians have to perform these really advanced psychrometric calculations. They're figuring out exactly how many commercial dehumidifiers and air movers are needed to overpower that ambient humidity. And it requires continuous daily monitoring to tweak and adjust the equipment as the space finally dries out. Finally, let's look at Section 5, mitigation versus restoration, the two distinct phases of recovery. Now that the science has done its heavy lifting, it's absolutely crucial to understand the divide between these two final phases of recovery. Mitigation always happens first. It's basically the defensive phase, stopping the damage from progressing through water extraction, emergency board-ups, and that intense structural drawing we just covered. Restoration, on the other hand, is the offensive phase that comes afterward. That involves actually rebuilding the home, putting up the new drywall, painting, installing the new floors. The big takeaway here? You simply cannot effectively restore a home until it has been completely and scientifically mitigated first. The ultimate goal of all these strict protocols, the thermal imaging, the complex psychrometric calculations, those crazy 60-minute emergency responses, is perfectly summarized right here. Your home returns to pre-loss condition completely. This whole scientific approach is specifically designed to entirely erase the disaster, ensuring that the structural integrity of your property is totally saved, and most importantly, your family's health is protected from mold and contamination. I want to leave you with this final thought today, because water is this invisible enemy that just loves to hide out in your subflooring and sneak behind your baseboards. If a pipe bursts in your home tomorrow, will you settle for a home that merely looks dry on the surface, or will you demand the exact science and protocol required to ensure it is truly dry? Understanding that difference is the ultimate key to surviving a water disaster. Thanks so much for joining me on this explainer. Keep learning and stay prepared out there.